To demonstrate this process of creating your feature definition list for inlets, I'm going to be referring to South Dakota DOT's standard drawing list. So first I'm going to go to the drop inlet section, and then I'm going to go into each standard drawing and identify what types of structures I have. So I see I have a type B, type C, type D, S, and so forth, but I also have different sizes. They're going to correspond to, depending on the size of the pipe that's connecting to the structure, it's the size that the box is going to be. And then when you go into the actual drawing, you're going to analyze it very closely to see what type of frames and grates are going to be used for each structure. Right, so once you make your initial list, so this is what I have here, is what I would consider an initial list. I would further recommend that you discuss this list with the hydraulic team that's going to be using it so that they can provide input as to what structures or structure sizes are rarely used versus commonly used. Make sure that you're including their commonly used structures. Also make sure that you have accounted for all the different frame and grate combinations that are used for each structure. You'll also want to make sure the name is clear. So consider adding corresponding pipe size ranges to the name so that it's clear when they use the feature which pipe sizes those are for. And when you're building this list, we want to make sure that we have a separate feature definition for each graphical representation as well as each hydraulically different structure. Okay, so what do I mean by graphical versus hydraulic differences? Right, so when we think of graphical differences, this is going to be the bottom size or shape of the vault, the type of grate that it uses, what size the grate's going to be, the number of openings, the type of inlet openings that you see. So that could be a curb opening, a grate, or maybe a combination of the two. You'll want to consider if it's a symmetrical versus non-symmetrical. So if we have additional curb openings upstream or downstream, and that changes whether you're placing it on the left side of the road or the right, you'll want to create a separate feature for each one of those options. We'll also want to think about the curb types, so depending on the type of curb that you're modeling inside of your cell, and then those construction class elements that I was talking about earlier. If you have a large number of possible sizes, you may opt to create a feature for each size range. So this could look like, less than 24 inch, or maybe a range from 24 to 48, 52 to 60, or greater than 60. You could choose that range yourself. And then for each one of those ranges, you're going to choose the most common size to graphically represent each size group. And this will greatly reduce the number of cells that you'll need to model. You may also choose to only model circular structures and not rectangular. Or if you have a certain inlet that can use different curb types, just use the most common curb type to represent the graphical model. Now, doing so, you need to realize that you are sacrificing the graphics. So your 3D model is not going to be as accurate as it would be if you had a separate feature definition for each type of structure. But something we don't want to sacrifice is the hydraulic side of things. So if it has a different grate type, or a different open area for the grate, or it's a different type of inlet, then we want to make sure that we're creating a separate feature for that, because that is going to drive the capacity calculations for these inlets. Another thing to consider is the curb and gutter properties. So when we are calculating spread and gutter depth, that always occurs at the inlets, and it's going to come from the curb and gutter properties inside of that inlet's prototype. Now, we could model the most common curb type, and then we could also pre-configure the most common curb and gutter inside of the prototype, and then per project the user could go in and change the curb and gutter type to whatever their project is using. And that would not sacrifice the hydraulic differences. It would just add an additional step on the user end. Some additional hydraulic differences to consider is the benching method that is used for each of the bottom structures, as well as the bottom size. Now, if you are using HEC 22 3rd edition to calculate your losses at the nodes, then the bottom size is actually not going to affect the hydraulics. So putting the features into those size ranges won't hurt you hydraulically. So these are all considerations you're going to make whenever you're building out your list. I always recommend to start small and then build out as you need to. And then one final point I want to make is that these construction class elements are very important. So anytime you're going to be reporting on a structure differently, or the placement point needs to be in a different location, or you need to grab a different station offset, the elevations are different, that is all going to demand you to create a different feature definition for those different cases.